Let's look at a more complex shear force and bending moment question. In this question, we're asked to calculate the reactions at the supports, which is our RA and RB. We're then asked to sketch the fully dimension shear force and bending moment diagram of the beam, and then calculate the maximum shear force and bending moment of the beam, and lastly, calculate the point of contraflexure. Let's start with our reactions as usual. The beam. Okay, so for our reactions, we're going to use sum of forces, sum of moments, and then we're going to use sum of forces to check our answer. So for R, to find our RB, we're going to take our moments at A, clockwise, positive, it's 0. And then the 0 is equals to, let's start from the first side. Let's start with the 3 kilonewton. So 3 kilonewton times 2 plus 4 plus 2 plus 4 plus 2 plus 2, which is 16, times 16, 16 divided by 2. Then we have 20. Both the 3 kilonewton is clockwise, since it's bending, since it's going downwards. The 20 is also clockwise, times 6, 6 divided by 2. 15 also clockwise, times 6 times 8. 2 plus 4 plus 2 is 8. The 10 kilonewton is also positive, is 10 times 4. 4 divided by 2 plus 8. Then we have the 8 kilonewton is multiplied again. We have the 8 kilonewton is also clockwise. 8 times 12 will be 14. 12 plus 12 times 12. And then we have our RB, which is going up and it's anti-clockwise, times 14. Then let's equate and find our RB. Every times 16. 16 over 2 plus 20. 6 over 2 plus 15 times 8 plus 10 times 4. 4 over 2 plus 8 plus 8 times 12. You're getting 60 minus RB times 14. Then now RB is 97.153 kilonewton. Now let's find our RA. Sum of moments at B, clockwise positive, 0. So we have 0. It's equals to, let's start with the 3 kilonewton. So for the 3 kilonewton, we have 1 3 kilonewton which is going clockwise, and the other side of the 3 kilonewton is going anti-clockwise at B. So we have 3 kilonewton times 2, 2 over 2 minus 3 kilonewton times 14, 2 plus 4 plus 2 plus 4 plus 2 times 14, 14 divided by 2. Then we have the 8 times 2. Then we have the 10 times 4 plus 2. Then the 15 times 6, 4 plus 2. After the 15, we have the 20. 20 times 6. 6 over 2 plus 8. 2 plus 4 plus 2. And then we have our RA, which is going clockwise also. Our RA is going up clockwise towards B. We have 2 plus 4 plus 2 plus 4 plus 2, which is 14. Now let's equate this. 3 times 2 times 1 minus 3 times 14. 14 over 2 minus 8 times 2 minus 10 times 4 over 2 plus 2 minus 15 times 6 minus 20 times 6, 6 over 2 plus 8. Then we have minus 1, 8, 7, 4 plus RA times 14. And then our RA is 133.857 kilonewton. Now let's check if our reactions are correct. To check your reactions, you're going to take sum of forces up. It should be equal to sum of forces down. So we have 133.857 plus 97.153. It should be equals to the 8, the 15, and 10 times 4, the 20 times 6, and the 3 times 16. One 133.857 plus 97.152. 231.01. 8 plus 15 plus 10 times 4 plus 20 times 6, 3 times 16, 231. So the difference, I think it's in the decimals. 160 divided by 14 is 97.3. 97.143 plus 133.857. Yeah, you made a mistake here. 97.143 kilonewton. 43. Then we get our 231. Now let's go through a second question. Let's put this that side. So the second question is to sketch and dimension the shear force and bending moment. Our RA was 133.857. Our RP 97.143. Okay, let me redraw this diagram a little bit bigger. Or should I? Let me extend it. This one. With 20, 15, 8, 3, and 10. Let's use this one for the lines. We're gonna extend this one from here, and then from here. Some more here. Okay. Separate this. Here. Whenever shear force calculations and bending moment calculations. With A, let's change the numbers. Let's call this one, let's say, with A, B, C, D, E, F. So this will be RA. A left, A right, B left, B right, C left, C right, B left, D right, A left, A right, left and our F right. Okay, let's put this in for shear force 0. Our A left will be 0. Our A right will be our reaction. One 133.857. Our B left will be 133.857 minus 20 times 6 minus 3 times 6. The 20, we're at B, our B is here. So B left we have this UDL as well as this UDL. Then we have minus 4.143. B right we have minus 4.143. Nothing else is happening. C left we have minus 4.143 minus our UDL, which is 3 times 2. This UDL in here, minus 3 times 2. We have minus 10.143. C right, we have minus 10.143 minus 15, which is this 15, setting at point C. Minus 25.143. Then D left, we have minus 25.143 minus these two UDLs, which is 10 times 4 minus 3 times 4. 10 times 4 and 3 times 4. Minus 10 times 4 minus 3 times 4. Which is minus 77.143 minus 77.143 minus our 8. Which is minus 85.143. Then A left, we have the UDL still. Minus 85.143 minus 3 times 2. Minus 91.143. A right we have minus 91.143 plus our reaction, which is 97.143. 97.143. Then we get a 6, positive 6. F left we have our 6 minus 3 times 2, which is the UDL. That's here. We get a 0, which is 0. Now let's plot our shear force diagram. Screen. That's what it's for. You see? It's just people. A left is 0, A right is 133. Let me put it up there. $133.857. I'll be left with -4. Let's see here, -4.14. B right to the same point. Then our C left is 10. $10.143. Our C right to have 25. Our D left 77. E right is 85. 143. Our E left is 1991. Then our E right is 6. Then back to 0. Okay. Bending moment is going to be shear. So for the bending moment, we are going to use these shapes here. Before I find the shapes, let's find this distance. So we have a 6 in total. You have a 6. And then you have an X. The X height is the 133 point something. Then the 6 height is 133.857 plus 1.143, which is 138. That's 138. So 138, it's 6. 133, it's X. Cross multiply, you have X is equals to 133 times 6 divided by 138. 133.857 times 6 divided by 138. We have 5.82. So I decide it's 5.82. 6 minus 5.82. 0.18 here. 0.18. We'll have 2. We have 4. We have 2 and 2. Let's shift. We shift the diagram over there. Just do that line. It's okay. It's doing two. We just put it around here. Okay, now let's do our bending moment and shear force diagrams. Our bending moment calculations, I mean. Just so we're going to have our A left. Let's call this point A prime. We're going to have our A prime left, B left, C left, B left, F, C left, D left, E left, and F left. So our A left is 0. Our A prime left we have times 1, 33.857 times 5.82. Then you have 389.524. Then B left we have 389.524 minus 1 over 2, 4.143 times 0.18. Then we get 389.151. Bring it down here. Just delete this for now. And then select to have the 389.151 minus this shape, which is a trapezium, 1 over 2 times 2, 4.143 plus 10.143, which is minus 1 over 2, 2 times 4.143 plus 10.143. With 374.865. Our D left we have this 3 with the 374.865 minus 1 over 2 times 4, 25.143 plus 77.143, and you get 170.293. Then E left is 170.293 minus 1 divided by 2 times 2. We have 85.143 plus 91.143. Minus 5.993. Then F left we have minus 5.993 plus 1 over 2 times 2 times 6. This should give you 0, but ours is not really at 0. 0.007. You can round off this one to a 6. Then yeah, that's how you do your shear force and bending moment calculations. Now let's draw this bending moment diagram. Let's use right. So A0, then our A prime is 389. Let's put it up here, 389.5, and then our B is 389. Let me put it almost close to it. Also 389. Our C 374. Wait, where am I forgot to add the forgot to add this point. So if A prime 389.5, and then B is 389.1 or 0.2 is okay. And then C we have 374.9. Then B we have 170.3. Then for E we have -6. And back to 0. So here we only have UDLs. So everything is going to be a curve. Still have a UDL there. Still have a UDL. Still have a UDL. Then still have a UDL. It's gonna curve back like that. Now that's our question B. Question C is saying calculate the maximum shear force and bending moment of the diagram of the beam. Our maximum shear force will be this one. That's Vmax, and our maximum bending will be this one. That's our Mmax. Then now let's find the point of contraflexure. Our point of contraflexure is this point right here. It's this point. That's our point of contraflexure. So to find this point, you're going to go back to your bending moment diagram and add that point, which is here. So it's either you'll use this side to calculate it, or you will use this side. but of course you're going to use the easier side. So you're going to split your beam at this point. So if this, the view reaction, and the vertical, this distance is 2 and this distance is x. Your reaction at B is 97.14. So you have 97.143. Now to find your x, you will take moments at this point, at P. So sum of moments at P, let's take clockwise positive, is equals to 0. So we have your 97.143 times x is anti-clockwise, is going up, and then plus your VDL, which is 3. We have 3 times 2 plus x, 2 plus x divided by 2. Or you can split your VDL and have this one and the other one, but yeah, it's going to be the same at the end. It's equals to 0. Now let's solve for this. So you have minus 91.143 x plus 6 plus 3x. You have 1 plus x over 2. So we're going to take this one in and in. So we're going to have plus 6x divided by 2 plus 3x plus 3x squared divided by 2 is 0. Now let's add the like terms. We have 3x plus 3x is 6x, and then minus it 10. Plus 6. So we have minus 85.143 x plus 1.5 x squared plus 6 is 0. Then you have a quadratic equation. In your calculator, 0.071 meters, which is your x. And you can see how small that point is, meaning it's correct. That's it for the video.